Now we pose the question. We see 6 graphs here. First question is, how well can each graph be represented by a power function? Talking about this graph, and this graph. And the related question is, answer the same question for the trend of the graph dictated by each of these data points. Okay, so what's the trend of the graph for this one? What's the trend for this one? What's the trend for this one? And how well can that be represented by a power function? So that's the question, and it's that simple question, and I'm going to leave it at that. Now in a subsequent video I'll give you some hints, but right there it is. These are all unlabeled, unscaled graphs. We don't do any arithmetic. We simply, or at least no scaling of the graphs, no numbers on the axes, no coordinates. We simply use what we know about power functions. What's the characteristic of a power function? What's the defining characteristic? Now, in some approaches, the defining characteristic is a power function y equals x to the p, or y equals ax to the p. We've seen that already. That's equivalent to the defining characteristic that when x doubles, y changes by a constant amount. The y factor is up. I said that wrong. So I'm going to start over.